Hello everyone. This video tutorial is solution of numerical problem 2.39 of chapter 2 free vibration with single degree of freedom system of book Mechanical Vibration by S.S. Rao 5th edition. The statement of problem is a pick and place robot arm carries an object weighing 10 pounds. Find the natural frequency of robot arm in axial direction for the following data. So L1, L2, L3, E1, E2, E3 they are given, and then outer diameter and the diameter of the shaft, those are given. So we are going to find out its natural frequency in axial direction. So it is in axial direction, it is assumed as a linear translational system, and for that linear translational system, natural frequency you can simply find out using k over m. So omega in this case is k over m. So at this point, like this one, its weight is 10 pounds. For this object, its weight is 10 pounds. So from weight, mass can be calculated, and then this stiffness of each hollow shaft in axial direction. So that can be found using modulus of elasticity. E is FL over AX, and in this case we can find out its stiffness. So from Hooke's law, F is equal to Kx, or K is equal to F over X, and from here this E, it is K L over A, and you have stiffness formula as EA over L. So first, stiffness of each section of arm need to be calculated, and that is EA over L. Length of each here is L1, L2, and L3, and then area of each is here because it is a hollow circular shaft, so area formula can be used here. So area of hollow shaft is pi by 4 outer diameter squared minus inner diameter square. So K1 is E1 over L1 into A1, and for first segment, its area is modulus of elasticity is E1 over L1 into pi by 4 di squared minus di is outer diameter minus lowercase di squared, that is inner diameter. So after substituting values of E1, which is 1 into 10 raised per 7, L1 is 12, and uppercase D1 is 2, and lowercase d1 is 1.7, so you'll get the value as 613.592 into 10 to raise power 3. So that is pound per inch. So that is the value of K1. So this value of K1, because I have to use it again, so I am going to store in the calculator. So here you have calculator. So if you're using FX991 ES plus, so then you can press shift, then on that recall button you have store, and then press A. Or if you're using CasioFX991EX, so then just store and then press A. So when you're going to store and press A, so on that top screen, so like here on that, so you will get as answer arrow A, so it's mean that it is being saved there. Or if you want to recall that A value, so in this calculator you will use alpha and then A, or if you're using that, so alpha, then A, so you can recall that value. Because I have stored that value in calculator as A, so just I am for my, so with the lead pencil, I can say it. I have stored this one as A in the calculator. Similarly, for second section of arm, K2 is E2 over L2 into A2, and then area of second one is pi by 4 d2 square minus lowercase d2 square, and L2 value is 10 inch, and then uppercase D2 is 1.5 and lowercase d2 is 1.25. When you are going to calculate it, so you will get 539.961 into 10 to raise power 3 pound per inch, and this value I am going to store in calculator as B. Now for the third section here, its L3 is 8 inches, its outer diameter is 1 inch, inner diameter is 0.75 inch. So I have substituted the values. After substituting the values, so I'll get that as 429.515 into 10 to raise power 3 pound per inch, and I'm going to store this one in calculator as C. Now these three members, so they can be represented as three springs with stiffness K1, K2 and K3, and this combination of springs that goes in springs in series. So when you have spring in series, so their equivalent spring stiffness can be calculated by using formula 1 over K equivalent is 1 over K1 plus 1 over K2 plus 1 over K3. So values of K1, K2 and K3 we have there. So we can just find out K equivalent for this system. So you have values of A, B and C, and to get answers with more accuracy, I have saved them in calculator as A, B and C, and now you can recall from the calculator, and it's very simple. So here you have button for alpha and A. So you can just simply put in calculator 1 over A plus 1 over B plus 1 over C. So alpha with B and alpha with C, or similarly in this calculator alpha A, alpha B and alpha C. So remember that you have saved them as A, B and C. So now you'll get answer in the reciprocal form as 5.80994 into 10 to raise power minus 6, and then from here you can find equivalent, K equivalent as a reciprocal of it, and it comes as 172.119 into 10 to raise power 3, and again because I have to use it again, so I am going to save in calculator as D pound per inch. Now to find next, its natural frequency, which is K equivalent over M under the radical. So mass is not given here, instead weight is given. So we will use the relation W is equal to mg, and then M is equal to W over G. So this equation can be modified as K equivalent into G over W. So next for natural frequency, K equivalent stored in the calculator, you can use it or you can directly put its value into G, and G in inch per second square, it is 386.22, and its mass weight is given as 10 pound. Remember that pound is a unit for weight and for mass in inch pound is slug. So then the answer for it is 2.578 into 10 to raise power 3, and its units are radian per second. So that is answer for this question. So natural frequency comes out to be 2.578 into 10 to raise power 3 radian per second. So that is the solution of this problem. Thank you very much for watching.